Okay, so my only intent is to go through lab values and some of the definitions. You can refer back to chapter 45 for these. All right, so urinaria, or without urine, that's less than 100 milliliters. Um, and dysuria is pain or discomfort or inability to urinate. Um, this is 100 to 400 milliliters. This is it goes from here to here. Your creatine clearance, if you remember, is a measurement of the creatine in your blood and in your urine. And I know this confused a lot of people, but basically you can take a sample from your blood, you can take a sample from your urine, right? Or you can compare the two and take it from both of them. Okay, so it's either from the blood or the urine that you're getting these lab values from. And I think that was really confusing to people, but your creatine clearance is going to be 24 hours. And it's going to compare the amount of creatine in your blood with the amount of creatine in your urine over a 24-hour period. You discard like the first urine, and then you get 24 hours worth of urine, and you compare it. So this is pretty accurate because creatine should be filtered through. All of these lab values are based on your body's ability to actually filter through something. So we know what can go through the glomerular filtration, and we know what can't. And we are using that knowledge to figure out, okay, based off these values, this is what you should or shouldn't have, okay? So that's creatine clearance. And your creatine clearance should be 60 to 70 to 135. And again, this is a ratio. It's comparing the two, okay? So this is 70 to 135 milliliters. Your complete urine composition is going to be from 2 to 24 hours, but you're going to pull up everything. So it's a complete workup of and it generally has specific things we're looking at. Gravity. Your gravity should be 1030 to 1003. Now your gravity is going to be sorry, I just messed that one up a little bit. Alright, so gravity should be 1.003 to 1.030. Gravity is measuring, here's your urine, and I want to know how many particles or how much insoluble things are in here. So that's what's measuring the gravity. So it's 1.003 to 1.030. Alright, the residual should be less than 50 milliliters, and you're going to have to catch somebody for this. But basically, it's after urination, how much is left in your bladder. It should be less than 50 milliliters, and of course, as you get older, you're gonna have more. All right. Albumin is this huge molecule, and it should not be filtering through your system at all. So you should have zero to trace albumin levels. All right. Your BUN is your blood urea nitrate. Your blood urea nitrate is going to be how much urea is in your system, and your blood urea nitrate should be from 6 to 20 milligrams per deciliter. All right. Urea obviously is a byproduct of protein breakdown, and it should be going through your system. So I should have some urea in there. Again, this is volatile because depending on cell destruction, whether you had somebody that just worked out, or you have somebody that has trauma, things of that nature, your urea could be completely different based off, catabolism or breakdown of muscles. So it could completely change. Anyways, so you have blood urea nitrate and creatine. Now we're talking about this. We're talking about the blood here. It's a blood sample. So just so you're checking that one. It's 0.6 to 1.3 milligrams per deciliter, and creatine should also be able to go through your system. So you should be able to get creatine out. Of course, BUN over creatine, this is a ratio, and an elevation in this ratio is going to indicate an issue with it. Uric acid is not something that we'll probably use as much, but you have the female uric acid, which is 2.3 to 6.3 grams per deciliter. Males are 4.4 to 7.6. And uric acid, if you remember, is a byproduct of purines. So you could have a metabolism issue here, or you could have somebody that just really likes sardines. Either way, it's not that accurate. pH should be 6. Remember, it's on the acidic side. Your red blood cells, you really shouldn't have red blood cells. Red blood cells are really big and shouldn't be fitting through your filtration. So you're looking at urine here. You're going to look at urine here. That makes me want to double check that one. But your white blood cells are a little bit smaller than your red blood cells. So when you're looking at your white blood cells, you'll have more in there. Okay, no, that was good. All right. So when you're looking at your blood cells, you should have really no blood cells in there. You should have no casts inside of your urine, and those are basically coming from the upper urinary tracts. You shouldn't have glucose, you shouldn't have protein, you shouldn't have ketone, which is breakdown fats. But so creatine clearance, again, that's comparison. Your gravity 1.003 to 1.030. So this was important. Your gravity is important. The residual is going to be important. You shouldn't have any albumin. That's also important. Bun is also used often. Your pH being off, that's going to be a good indication for you. And you can look at this creatine, but again, these two can really be affected by some other things. You should never have past glucose or protein or ketone in your urine. So just remember, you can get these samples from either your blood or your urine. And of course, you're going to need to know all your electrolytes. So I'm going to quickly go through the electrolyte story one more time. I don't foresee uric acid being something that is as useful. And your creatine clearance is probably the best indication of your glomerular filtration rate, because you can compare it to what's in the body to how much is actually coming out of the body. So that's why that's a little bit more useful. All right, so last time, MG, surfer girl with a rocking body. All right, she likes to go to the ocean. She's MG, and she likes to go to the ocean quite a bit. She spends 1.5 to 2.5 hours in the ocean because she likes to surf. All right, it's of course extremely hot outside, and she stays in the water for about. She takes a break about 1:35 to 1:45, which is about lunchtime, and that's about lunchtime average. So she takes a break from the ocean at about 1:35 or 1:45. Because the chlorine's really bothering her eyes, and it's hot outside. And if you know that heat and chlorine makes chlorine gas, then you will understand why it's going to be bothering her. It's very hot outside because we're talking about California. So it's 96 to 106 degrees. So she does take a break about lunchtime. She decides to go onto the beach, and even though she doesn't need it because she has this wonderful metabolism, it's got an hourglass figure. She's got a metabolism of 22 to 26-year-old, but she's still on a banana and milk diet, anyways, because that's what Shape Magazine told her to do. Here's our milk, here's our banana, that's my representation of a banana. Okay, so she's on her milk and banana diet. She eats 3.5 to 5 bananas. She drinks 8.6 to 10.2 gallons of milk, which is of course a ton. And she waits out on the beach for her rock star boyfriend, who her parents hate, because he's got a mohawk and lots of piercings everywhere. Anyway, his name is Foz, and he is always late because he thinks he's a rock star. And Foz is supposed to come pick her up at 2:45. That's his guitar, by the way. There we go. Alright, so Foz is supposed to come pick her up at 2:40, but he's 2 hours late, so he comes at 4:40. So there you go. Magnesium 1.5 to 2.5, sodium 135 to 145, chlorine 96 to 106. This is metabolism for your bicarb. But anyways, metabolism 22 to 26. Milk 8.6 to 10.2. Potassium is 3.5 to 5, and of course phosphorus, our rock star boyfriend, is 2 hours late and comes from, it's supposed to come at 2:45, comes at 4:45 instead. All right, and those are your values.